In this video, I'm going to be going over question number 20 from the AICE Physics syllabus code 9702, paper 11 from May-June 2018. The question reads, a transverse progressive wave is set up on a string. The graph shows the variation with time of displacement for a point on this string. And you can see the figure there. The separation xy on the graph represents the blank of the wave, that's labeled 1. X and y have equal 2. Okay, and we can see our answer choices here have sort of columns 1 and 2, and we are to find the corresponding terms that belong in here. One of the key things about sort of just any kind of graphical analysis is looking at what's being plotted against what. So here we see displacement against time. So time being plotted on the x-axis means that this sort of space from x to y, this being an identical point on it, well, that's got to be the time period of the wave, right? So they're plotting time, so it's time period, pretty straightforward. Wavelength would only be true if they were plotting distance here. So those are typically the two kinds of graphs you'll see with the wave: displacement on the y-axis against either time or wavelength. And when we're looking at sort of the physical space between two identical points on the wave, that represents either wavelength or time period, depending on sort of what we're plotting here. So this is the time it takes the wave to oscillate. By this sort of point, again, it's completed one oscillation, and so the time that is represented here on the x-axis, that's the time period. X and y, we can see, have equal displacements, right? Because they're at the same y coordinate on the graph. The amplitude is the maximum displacement. So this point and this point, the crests of the wave, and this point and this point, here the troughs of the wave, are the amplitude. So the correct answer is B for this one.